Number 1 asks us to simplify, and it gives us the product. So when you go to solve this, this is number 1 for anybody who just joined. When you go to solve this, you could first move any of the negative exponents if you want and make a fraction, because those are going to move to the opposite side. I also know if I make a fraction that this 3 is going to follow to the denominator, because that's what a fraction is. Or I could simplify as it is now, combine as many like terms as possible, and then move at the end. Either way, if you do it correctly, you're going to come out to the same answer. So I'm going to do it that way because it's the most straightforward for you guys. So when I say combine like terms, I mean anything that has an x as a base, I'm going to put together. Anything that has a y as a base, I'm going to put together. Anything that has no variable at all, I'm going to put together. When we multiply these together, what happens to their exponents? They add. Okay? So I'm going to start with my non-variables. So I have 2 and 6 and 1/3. So what's 2 times 6 times 1/3? 4. 2 times 6 is 12. Times 1/3 is the same as divided by 3, which makes it 4. Then I do the same thing. I'm going to do my x's. So I have x squared, x to the negative 3, x to the negative 1. Since I'm multiplying those, I'm just adding their exponents together. So I have 2 minus 3 is negative 1. Minus 1 is negative 2. So those simplify to x negative 2. And then I do the same thing with my y's. So I have y negative 5, y, and y cubed. Remember, if there's no exponent present, we assume it's a what?
1.
1. So this is the same as y to the 1. We add the exponents together. Negative 5 plus 1 is negative 4. Plus 3 is negative 1. So when I put together like terms, I get 4x negative 2, y negative 1. Can I leave it like that? Why not? Negative exponents, so I need to move those. We can never leave a negative exponent. We can never have more than one of the same base. So where are those negative exponents going to move? Denominator. Is the 4 going to move with them? No, they are separate terms. So then this is the same as 4 over x squared y. And then that's your final answer. Any questions on that one? Okay, number 2. Anybody need to go over it? The biggest mistake I saw is that people were not converting 6 feet into 72 inches because my equation was given in inches. So you need to make that conversion before you plug it in. Any other questions on that one? Okay, number 3 was a factoring one. Who would like to go over this one? Okay. A specifically, got it. Okay, so this is 3a. And I have x to the 16 minus 1. So as I'm looking at this, we need to remember some special case factoring that we've done previously. This is a difference of squares because I know x to the 8th times x to the 8th gives me x to the 16th, and 1 times 1 gives me 1. Since it's a difference of squares, it's going to factor into the same factor twice, but one's going to be addition and one's going to be subtraction. So then this factors into the x to the 8th plus 1 and x to the 8th minus 1. So I just took one of each of these and put them in each of the factors and made 1 plus and 1 minus. However, yeah, it should be x8. Because 8 plus 8 is 16. So from here, I have another difference of squares. Because x to the 8th is the same as x to the 4th, x to the 4th. And negative 1, or 1 is the same as 1 times 1. So that one's going to factor out farther. Same process. 2 factors, 1 addition, 1 subtraction. So then this one becomes x to the 4th plus 1. x to the fourth minus 1. And then I get to do it again because I have x to the fourth minus 1. X to the fourth is x squared, x squared. 1 is 1 and 1. So then that one breaks down farther into x squared plus 1 and x squared minus 1. And then wouldn't you know it, I get to do it again because x squared minus 1, both of those are squares. X squared is x times x. 1 is 1 times 1. So then that one breaks down into x plus 1, x minus 1. So then all of my factors are the x8 plus 1, x4 plus 1, x squared plus 1, and then the x plus 1, x minus 1. And I would write those out as a product. Questions, concerns, or issues on that one? Okay. If I gave you one like this on the final exam, it would not have as many steps to it. It would be like 2 of those levels, not all 4. Questions, concerns, or issues with that one? Does it make sense seeing it now? Okay, so then if I were to take it one step further and ask you to solve this, what would I do with each of those factors? Set them equal to 0 and solve. Okay, so some of them would require the quadratic formula. Technically that one could too, and then break it down farther, and so could the x8. Okay, any other questions on A? B is going to be a quadratic. Would we like to see B? Okay. Since we're here, right? As well. Okay, 3B is 8c to the 6th plus 19c cubed minus 27. So as I'm looking at this right now, it doesn't fit any form that I have previously factored, but I do notice that the exponent on the 8, or my first term, is twice the exponent on my middle term, which indicates that this is a quadratic. So in order to make it look like a quadratic, which will allow me to factor it more easily, I'm going to do a u substitution. So I'm going to say that u is equal to c cubed. By doing that, I can rewrite this as 8u squared plus 19u minus 27. And now that looks like a quadratic to me. Everyone see what I did? From here, you could use the quadratic formula if you wanted to. Just know that since I'm not looking for the zeros, whatever zeros I get, I would have to rewrite as factors. Or we could try to factor it using the rainbow method. We're going to do rainbow because we haven't practiced that in a long time. So when I do rainbow, I take this 8 and I multiply it into the negative 27 at the back. When I do, I'm left with u squared plus 19u minus 216. So then when I factor this, I'm looking for 2 numbers that multiply together to get negative 216 and add to get a positive 19. Anybody have any ideas? 27 and 8. So this factors into u plus 27 and u minus 8. But what do I need to do next? Since I rainbowed. Divide the 8 back out. This is super duper awesome because the u minus 8, when I divide that by 8, it's just going to be u minus 1. This one does not reduce, so I kick the 8 over with the u. So now I have 8u plus 27 and u minus 1. Am I finished? Why not? I didn't originally have a u in this problem, so I need to replace it with its original value. We did u equals c cubed, so I need to replace the u now with a c cubed. When I do, I get 8c cubed plus 27, and I get c cubed minus 1. Here's another beautiful special case. These are sum and difference of cubes. So they have a special factoring method as well. So we're going to do the 8c cubed plus 27 first. The first thing I need to identify is the cube root of each of those terms. What's the cube root of 8? 2. And then what's the cube root of c cubed? C. So then the cube root of that whole term is 2c times 2c times 2c. What's the cube root of 27? 3. When I factor a sum or a difference of cubes, it's going to factor into 2 factors. One of them is going to be a binomial with 2 terms. One of them is going to be a trinomial with 3 terms. To create the binomial, I take one of each of my roots in the same order they were written in the problem with the sign of the original problem. So the first factor on this one is 2c plus 3. Once I use one of my roots, I get rid of it, so I don't use it again. Everyone okay with that? So I just pulled one of each of those down to my binomial. Then I fill in my trinomial with the roots that are left. So 2c times 2c becomes 4c squared, and that's the first term in my trinomial. My third term then is 3 times 3, which is a positive 27. The middle term is the one that we have to now create. So to, that's 9. Yeah, thank you. To create that middle term, I take my binomial roots, multiply them together, and apply the opposite sign. So 2c times 3 is 6c. Opposite sign makes it a minus 6c. Neither one of those can be factored any farther, so I'm done there. And then we do it all minus 1, because that is a difference of cubes and it works the exact same way, except this is going to be a minus and that's going to be a plus. So let's do it. Cube root of c cubed is c times c times c. Cube root of 1 is 1, because 1 times 1 times 1 equals 1. We pay no mind to the sign in front of our last term. I go ahead and I write my parentheses that are going to outline my factors. The first factor is one of each of my roots with the sign from the problem. So c minus 1 is my first factor. I take the 2 c's that are left and multiply them together to get c squared, which is the first term in my second factor. Then I take the 1 times 1 that's left, multiply it together, and get the third term in that second factor. And then to get the middle term, c times negative 1 is negative c. Opposite sign makes it a positive c. Neither one of those can be factored anymore. So then I stop there. How do we feel about that? I will tell you that the problems that I use for your final exam are easier than the problems contained in this review packet, if that makes you feel any better. Any questions on A or B for number 3? Okay, number 4. C specifically. C specifically. Okay. Any major questions are on A or B? A, you just factored the numerator and factored the denominator and then looked to see if anything canceled. B, you had to create a common denominator. So I look at the factors that are already there and I figure out what I need for them to be the same. And I multiply that into each of the individual numerators and then simplify. Any major issues there? Okay, so then C, what is C?
Oh boy.
Yeah, we're not going to do that one right now. I'll work that one out because it's going to take too much time. But I will work that one out in a separate DocCam video. And honestly, I'm not going to give you one that big on the final exam anyway. But I will work that out separately. I just don't want to take like the rest of class to do that. So I will start that one. Any question on number 5? Are we all okay with number 5 and how that one's done? No? Okay, just to review, because I'm not so sure that you guys have seen my answer key, so know what I'm talking about. It would not be a bad idea to have it up in front of you right now while we go through this, just saying. So for number 5, I'm going to read it, and then I'm just going to tell you how we set it up to make sure everybody set it up correctly. So it says, a healthy heart beats 70 to 90 beats per minute. Estimate the number of heartbeats in the lifetime of an individual who lives to the age of 80. Okay, so there was kind of a lot of information there. The first thing I need to identify is what the average beats per minute is for that person, or for the average person. So if it averages 7 to 90, what's halfway between 70 and 90? 80. So we're going to say that a person averages 80 beats per minute. I'm going to say BPM. I need to figure out how many beats that is for 1 year of life then. So I need to take that 80 and I need to multiply by the number of days in a year. How many days are in a year? 365. Then times the number of hours in each day. 24. Then, because it's beats per minute, how many minutes are in each hour? Am I finished there? I calculated the number of beats per minute for an entire year. But was I just looking at 1 year of life? I was looking at for 80 years of life. So then I just put that all in my calculator. And we should end up with the number . Oh my gosh. Approximately 3,363,840,000 beats in that lifetime. Average. Okay, so the hardest part is just remembering all the things that we need to multiply by. So I like to label underneath so I keep track. Any questions on that one? Okay, number 6. Anybody want me to go over that one? That was a grouping one.
B.
Okay, that's fine. I'll go over B. So 8A was just grouping. I took the first 2 terms, pulled out a common factor. Took the second 2 terms, pulled out something that gave me the same factor in the parentheses, took out what they have in common, took out and rewrote what I took out of each of them, set each of that equal to 0, and finished. If you have any questions on that, let me know. So then 8B is a lovely absolute value problem. I know you're all loving that one. I think it's 8B, but it's 6B. So I have 2 is less than the absolute value of x minus 6, which is less than 4. Whenever I have something like this, I always like to separate it into 2 problems and then go from there. So I'm going to go ahead and do the 2 is less than the absolute value of x minus 6 first. And then I'm going to do the absolute value of x minus 6 is less than 4 as my second problem. Okay, so here's the key. What does the absolute value do for whatever's inside of it? Turns it positive if it's not already positive, which means I could end up with a negative inside of there as well. So whenever we're doing an absolute value and an inequality, I have to consider both the positive and the negative versions here. So I not only am going to compare it to 2, but I'm going to compare it to -2 as well. When I compare it to the negative version, I have to flip the sign. Okay, also when I split it up, I lose the absolute value signs. So then this becomes 2 less than x minus 6 and -2 greater than x minus 6. So I added a negative and then flip the sign. I'm going to do the same thing on this side as well. Okay, so whenever we have an absolute value, we have to accommodate for the fact that it could have been negative before we applied that. So then I'm going to compare it to -4. I'm going to flip the sign, and I'm going to drop the absolute value symbols. And then I just solve each of these. So on this one, I'm going to add these 6 across. And when I do, I get 8 is less than x, which means x is greater than 8. On this one, I'm going to add the 6 across. And I get 4 is greater than x, or x is less than 4. I do the same thing over here. I add the 6 across, and I get x is less than 10. I add the 6 across, and I get x is greater than 2. So then I need to figure out what this is telling me. There are a couple different ways you could do that. You could do a number line and plot each of these individually, which would give us our solution set. Or we could just compare, put x in the middle, and evaluate that way. So on this one, I have x is smaller than 4. If it's smaller than 4, then that also has to be bigger than something on the other side. What is x bigger than on any of these other ones? Well, I have x is bigger than 8 or x is bigger than 2. I have to have a number smaller than 4 to compare it to. So I say the 2. I also had an x is less than 10, which means x has to be bigger than something that has to be smaller than 10. The only one that makes sense is x bigger than 8. So then I end up with the solutions. X is between 2 and 4, and x is between 8 and 10. Any number on those intervals is going to work. So then how do I write my final answer? When I'm talking about inequalities, how do we normally do it? Interval notation. So x between 2 and 4, and x between 8 and 10. Why am I not using hard brackets on those? Because it's not equal to, it's a single inequality. And then that's my answer. If I were to give you one like that on the final exam, I would not make it a compound inequality. So it wouldn't have 2 inequalities in the problem, it would just be 1. Just because of time.
That's nice.
Right? As I said, all the problems on the final are easier than the problems on here. Good, I'm glad. Questions, concerns, or issues with that one? Okay, so then that was 6B. 6C should be pretty easy. It's just working backwards. How about D? This was honestly one of my favorites on here, I'm not gonna lie. Anybody want me to go over 8D or 6D? Yeah, I figured. Okay. So 6D says to solve for H. What'd you say, Nicole? Okay.
I don't
Okay.
know. I think it looks right.
How many more problems can we go over? 8:15. We'll do 2 more.
Oh, we'll try.
This one.
We'll try you. Okay. So on this problem, my goal is to solve for H. So what's the first thing that I need to undo or change?
The
The root. I need to get rid of that square root because I can't solve for something that's under 1. So how do I undo a square root? Square both sides. So when I do, I get c squared equals 4h times 2r minus h. What do I do next? How many h's do I have right now? 2, but not every term has an h on it, so I need to do something maybe to try and group all my h's together. The only way to do that is to expand that right side first. So I'm going to multiply out the 4h into both of those terms. When I do, I get c squared equals 8rh minus 4h squared. What does this kind of look like to you? I have an h squared, I have an h, I have a term that has no h on it. Becca, see that ladder? Looks like a quadratic to me. I know, it's disgusting, but it's fun. So now that it looks like a quadratic, I really need to make it look like a quadratic so that I can solve it, which means I need to get all of my terms on one side of the equal sign. I also want my h squared to be positive, so I'm going to add everything from the right over to the left. When I do, I get 4h squared minus 8rh plus c squared equals 0. Right? Everybody see what I did? This is the part where you're going to get confused. How do I solve a quadratic like this? Quadratic formula. Because factoring is going to be a little bit difficult right now, so I'd really not try and deal with that. When I do the quadratic formula, anything that's not an h is considered part of my coefficient. So on my h squared term, my a value is 4, because that's everything that's not an h. On my b term, which is my h term, the negative 8r is my b. And my constant at the end has no h's at all, which means that c squared is that constant term c. So using those a, b, and c, I'm going to plug it into the quadratic formula and solve. So in case you can't remember what the quadratic formula is, hopefully it's somewhere in your brain. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to plug in that a, b, and c that I found over there. So when I do, I get positive 8r plus or minus the square root of 8r squared minus 4 times my a value of 4 times my c value of c squared all over 2 times my a value of 4. From here, I'm going to go ahead and simplify as much as I possibly can. The 8r out front just stays 8r. I can't do anything with that. Plus or minus the square root of, what's 8r squared? 64r squared. I just square each of those terms. So I have 64r squared minus, what's 4 times c squared? 16c squared. So minus 16c squared all over 2 times 4, which is 8. That looks really, really ugly to me. So if I can simplify it, I would really, really like to. The only way to simplify this is to be able to take a perfect square out of those 2 terms that are inside of my quadratic formula, square root, sorry. I cannot square root into each of those individually because they're not being multiplied together. That doesn't mean, however, that there's not a perfect square that was multiplied into both of those. So what can I take out of both 64 and 16? 16, right? 16 times 4 is 64. 16 times 1 is 16. So then this becomes 8r plus or minus the square root of 16 times 4r squared minus c squared. Since I have a 16 being multiplied into both of those, and 16 is a perfect square, I can take the square root of 16 and put it out front. What's the square root of 16? 4. So then this becomes 8r plus or minus 4 times the square root of 4r squared minus c squared over 8. Is that as simplified as I can go on this problem?
Hopefully.
No, why not?
Yeah.
I can take a 4 out of 8, 4, and 8. So when I take a 4 out, I'm left with 2r plus the square root of 4r squared minus c squared over 2. Questions, concerns, or issues? I forgot to put over 2 on my key, so I'll fix that one. How do we feel about that? All right. Just seeing it make it a little bit easier. Okay. See how much time is left. We have 12 minutes. Do you guys have another one you'd like for me to go through?
9.
How about 7 or 8, since I don't want to skip over those if people need them.
I have a quick question.
Yeah.
8.
Yeah.
Aren't you supposed to put 20,000 in? Like,
Yeah, should have been just 20. That's okay.
uh,
I'll fix that too.
because I don't think there would be
Sure there would.
a
Come on.
billion.
Sure there would. No, I'll fix that.
Yeah.
Okay, so number 9 is the next one we want to look at, right? Okay. So number 9 says, for what values of A is the distance between A1 and negative 2A less than 3? So what equation am I going to need for this one? The distance one. And it tells me that the distance between any 2 points is equal to x2 minus x1 squared plus y2 minus y1 squared. The 2 points that I was given in the problem are A1 and negative 2A. It doesn't matter which one of these you apply to be point 1 and point 2. So I'm just going to say that the first one is x1, y1, and the second one is x2, y2. It does not matter, though, if you chose to go the other direction. Like if you said this was x1, y1. So then I just plug those into my distance formula. When I do, I get negative 2 minus a squared plus a minus 1 squared. Am I just trying to find the distance, or am I comparing the distance to something? What does my distance have to be? Less than 3, which means that this distance formula is less than 3. So we need an inequality in there somewhere. My goal is to get a by itself. So the first thing I need to do is get rid of that square root. How do I get rid of a square root? Square both sides. when I do, I'm left with negative 2 minus 8 squared plus a minus 1 squared is less than 9. I need to FOIL out each of these on the left-hand side. So remember, negative 2 minus a squared is the same as negative 2 minus a times negative 2 minus a. And then a minus 1 squared is a minus 1 times a minus 1. All still less than 9. I FOIL these out. So when I do the first one, I get a squared plus 4a plus 4. And then plus, I do the same thing with this right-hand side. I get a squared minus 2a plus 1. I can go ahead and put together my like terms. A squared and a squared is 2a squared. 4a minus 2a is a positive 2a. 4 plus 1 is 5. And then less than 9. I'm going to pause here to get you guys to catch up.
Lucky when you get to the next page.
What do I do from here? Subtract the 9. This is a quadratic, which means if I want to solve anything related to a quadratic, I need all my terms on one side, and I need to be compared to 0. So I need to subtract the 9 over. Joe, do you have a question? Okay. So when I subtract the 9 over, I get 2a squared plus 2a minus 4 is less than 0. And then I can either quadratic formula this or I can factor it. It's entirely your choice. Let's factor it as a practice. What can I take out of all three of those terms? 2. So when I take it out, I'm left with a squared plus a minus 2. Do I know two numbers that multiply together to get negative 2 but add to get 1? 2 and negative 1, right? So then this becomes a plus 2, a minus 1. I set each of those equal to 0, and I get a equals negative 2.
Wait, less than 0 or equal?
Less than 0. We always compare to 0 with a quadratic. I find what would potentially be my zeros, which are negative 2 and 1, so that I can put those on a number line and compare numbers around them to identify my solution set. So what I'm going to do is I'm going to pick a number on each of these intervals. I'm going to plug it in, and I'm going to see if my answer comes out to be something that's less than 0, because if it does, that interval works and is part of my solution. So what's a number to the left of negative 2 on the number line?
Negative 3.
Negative 3, so let's plug that in. It does not matter if we plug it in here, or if we plug it in here, or if we plug it in down here. It does not matter where we plug it in at. So let's just say, for good measure, we'll plug it into this one. Yeah. What you thinking, Gabe? Are you doing the math?
I didn't think it through out. So
If you didn't take a 2 out, did you quadratic formula it or factor it? Okay, did you come out with the same answers?
No.
That's fine. Okay,
Why?
you always have to take a common factor out if you're factoring. If you're quadratic formulaing, you don't. But for factoring, you do. Okay, what happens when I plug negative 3 in? What number did you guys get? Somebody tell me they got something.
Oh, we're sitting here waiting for Gabe to think about it.
Did anybody plug negative 3 into this equation? No, so let's do it together. What's negative 3 squared?
18 plus
9 times 2 is 18.
18 minus
Negative 3 times 2? Negative 6. And then minus 4. What's 18 minus 6 minus 4? Is 8 positive or negative? Is that less than 0? What's the number between -2 and 1? 0. What happens when I plug 0 into this equation? I get -4. -4 is less than 0. What happens when I plug in a number greater than 1? So say like 2. 2 squared is 4, times 2 is 8. 2 times 2 is 4, and then -4. I get positive 8, which is not less than 0. So what's my solution set? Which interval worked? -2 to 1. Am I including -2 and positive 1? Yes or no? No, because this is a single inequality that did not include equals on it. So just -2 to 1.
That was bad.
Fix that one. Okay, questions, concerns, or issues on that one? Okay, we're gonna stop there. And then we will pick it up again tomorrow.